No decimals today. All day long. Not in algebra one. I mean, we're gonna do some word problems. Actually, we're gonna do word problems involving money, and then we'll have decimals. And we'll do some other word problems. We might have decimals, but outside of word problems, no, we're gonna stick not to decimals. Okay. So we're working towards the goal of solving equations, and then this skill that we just learned yesterday about these rational exponents is going to help us with that. So for number one, your first step should be to rewrite as a radical. And I need you to show the work on this, or I can't give you credit. Because you do have calculators, you're supposed to have calculators. So when I rewrite it as a radical, the denominator becomes the index. So if you weren't here yesterday, this is what we practiced yesterday. So I'm going to rewrite this problem. Instead of 27 to the 1/3, that's the equivalent to the cube root of 27. So now I have to think, what to the third power is 27? What to the third power equals 27? And so the more you have like lists of powers in your notebook, the easier it's going to be, especially if you don't have a calculator. So maybe I'm going to come over here and I'm going to leave this here today. 2 to the third power would be 2 times 2 times 2, which is 8. 3 to the third power is 3 times 3 times 3, which is 9 times 3, which is 27. So it turns out 3 to the third power is 27. So if I rewrite this, if I rewrite 27 as 3 to the third power, yesterday I told you, you can show that an index and an exponent cancel out. They're inverses. So my result is just 3. The radical bar is gone. The cube root of 27 is 3. Let's try number 2. Rewrite it as radical. It's 256 raised to the 5/4 power. 4, that's greater than 1. Okay, so the denominator goes down and around and becomes the index. What happens to the numerator? Yes, it stays an exponent. So I bring the 4 down and around, it becomes that little guy. And then this 5 stays an exponent. The numerator stays an exponent. So I'm going to ignore the parentheses and that 5 on the outside. And right here, I just have to do some thinking. What to the 4th power is 256? Don't call it out. Think, what to the 4th power is 256? For our use today, I'm going to make a list over here of powers of 4. 2 to the 4th is 16. And 3 to the 4th is 81. Anybody know 4 to the 4th? Show your calculator. 4 times 4 times 4 times 4. 256. So inside here, I just have a 4. Can I skip this step? The fourth root of 256 is 4. I now have 4 to the 5th power. So again, calculator. 1024. So you gotta show work though. And some of you are with your calculator, you can do this pretty quickly. You've seen how to use your calculator, right? But you gotta show what your calculator's doing. Understand how your calculator's coming up with the numbers. Alright, I'm gonna pause on 3 and give you guys some time to try it. Now that we've walked through 2 kind of. Teamwork.
Look up in the board. I need it real quick. Stop. I'm trying, but I already got the answers. I can write it. Shoot. What's 10? Oh, I've I find it does, if I'm being honest. I was about to put that down, but I can't really write numbers. Yeah, but this is what I need to see. Oh, you got your paper, huh? What was it? What was it? Huh? What was it? Huh? Where was the hiding? Right? Bullshit. have A's. You can't get A's in your hand, so you might need to learn some math. I literally did a report on A's, so you can't. I literally did a report on A's. I had to research A's. Because she's being mentally retarded and she's acting like she's smart. Alright, take a fight.
I got $200 on my business.
Alright, you guys, I'm gonna show the work. Here's the answers. I'm gonna show 16 right now. This is the answers, and I'm gonna show how you do a fraction right now. So fractions in most mathematics are more complicated, right? For the most part, Johnny, for the most part, fractions are more complicated. But here, in this case, they really aren't, because it's just the top and bottom separate. Okay, so because there's a little 4 here, I'd like to see you write this with the 4 down and around.
I didn't get it wrong. I didn't set it up.
And then, even though this is a fraction, it really isn't that much more complicated, because we're just going to do the top, and then we're going to ignore the top, and then we're going to do the bottom. Right? So, you don't have to think about like common denominators or reducing or anything like that. It's just top start from the bottom. So, the fourth root of 16 I can see here is 2. And the fourth root of 625 I can see is 5. So that's my answer. So while it looks intimidating as a fraction, you just do the top number, leave it on top, do the bottom number, leave it on bottom, and that's it. Okay. Yes, that's right. 13. So we're going to bring the denominator down and around, and this is the fifth root of 1 over 32. Lost? Yeah. Lost on the word. So it's the fifth root of 1 over the fifth root of 32. I never put 1 up here in the list, and that's a fail on my part. I should. 1 of the third is 1. 1 of the fourth is 1. All of your roots of 1 are always just 1. 1 times itself is 1. And then 2 to the 5th power is 32. I'm going to add that up here. 2 times itself 5 times is 32. So down here, that's where the 1/2 comes from. So leave it, if it's on the bottom, leave it on the bottom. Other questions? Alright, so if you look at the bottom of the workbook page, you're solving equations. I'm going to teach you how to do that today. It's pretty advanced, so let's get into it. Advanced is exciting. I'm excited about advanced. Yeah. Definitely. Without a doubt, I like to do more.
Oh, I know do we like they gave us the answer, right? And then we have to find what would do to it. Actually, we did 5 times 4. Wouldn't it be fifth root for this one?
No.
Wait. 25, 13. Oh no, never mind.
Hey.
Here it is. Alright, check it out, guys. So this is our third day in this section. I've had you for 3 days now. I've had you title your notes chapter 7-3. So the reason we're spending more time in chapter 7-3 is because it's actually brand new to you. You haven't done this content before. So we're still in 7-3, taking it one day at a time. And this is a power property of equality. And we haven't done this since we've been back from break. Today we're actually solving equations. We've been simplifying things. We've been rewriting things. We've been using all these properties with exponents. And today we're actually going to use those skills to solve equations. Okay, the more you can understand this equation, the more you can buy into this process. Let me write it nice and big for everybody. If 5 to the x equals 5 to the third, if 5 to the x truly is 5 to the third power, what does x have to be? X has to be 3 here. For this side to be the same as this side, that will only be true if x is 30. You got to buy into that. And if you can buy into that, you can do the whole thing. This statement tells me that x is the same as 3. If the left side really is the right side, x is another symbol for 3. So here's the process. If the base is the same, I should not say that. If the base is the same on both sides, if the base is the same on both sides equal, we have a base 5 and a base 5. Then we can set the exponents equal to each other. So the way we describe it is by dropping the base, which is like a song. I'm going to drop the base, and I'm going to say that x is 3. If the base is the same, you can totally drop it out of the problem and set the exponents equal to each other. That's a property of equality. Drop the base. Drop the base and set your exponents equal to each other. So then what is key is actually having the same base on the left and the right side. So the work here is creating the same base on the left and right side of the equation. So that'll be what a lot of our discussion's about, is how do you create the same base? Paper towels. You guys ready to try one? Let's do some work. Let's work it out. Work it out. Boom, here we go. 9 to the x power is 729. So I'm going to write down a step for you. Or maybe I'll call it a goal. My goal is to create the same base on both sides. I would love to have base 9 on the left and base 9 on the right. So my question for you is 729 a power of 9? So could I rewrite 729 as though it was 9 in an exponent? Let's find out. So I know what 9 to the first is 9. Do you guys know what 9 squared is? 81. 9 times 9 is 81. Does anybody know what 9 times 9 times 9 is? What? That's the number we're looking for. Okay? So I'm going to replace 729 with 9 to the third power because it's the same thing. So my new equation will be 9 to the x equals 9 to the third. I'm taking this out, and I'm putting 9 to the third in because it's equivalent. And once you meet that goal, once you've created the same base on the left and right, you can drop the base like a DJ. And equate exponents. So I'm going to now drop the 9s and go ahead and say that x has to be 3. And when you look at the original problem, it makes sense. 9 to the third is 729. So x is 3. Makes perfect sense. So this is the main concept. Our next problem is much more challenging. So get ready. Who's ready? Boom. It's not just as easy. I thought it was at first too, and then I thought, no, this is not just as easy. My goal is to create the same base. So I have to think what number raised to an exponent could be 16 and 8. Does anybody know? It's 2. I had to tell the last class, but it's 2. So let me look at my powers of 2. 2 to the first is 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. And 2 to the fifth is 32. Alright, great. So what we're going to do here, this is the legit strategy, is I'm going to take 16 out. And I'm going to put 2 to the fourth in because it's equivalent. And I'm going to take 8 out on this side, and I'm going to put 2 to the third in. So I'm searching all of my knowledge of numbers. I'm using a tool, a calculator, and I'm figuring out how can the left and the right be written in the same way. So instead of 16, I have 2 to the fourth, and its little exponent is still out there. And instead of 8, I have 2 to the third. And that is how mathematicians have figured this out. They break it down. No, now we got to follow our properties of exponents here. We're going to distribute. So this is 2 to the 8x minus 4 equals 2 to the third. And now we have the same base. We're going to drop the base and equate exponents. I love the word equate. So I'm going to cross these 2's out. If the left truly equals the right, I can say that 8x minus 4 equals 3. I drop the 2's and I equate exponents. Now you have this multi-step equation here to solve. Told you it was a challenge. Alright, so I'm going to solve this now. I'll add 4 to both sides of the line. I get 8x equals 7. Get x alone, I'll divide by 8. And x in this problem is 7 over 8. Well, this isn't something that you should have to remember here. Solving this equation is something that you should just know how to do now, because you made it through semester 1. You do opposite operations, you know. If it's a plus, you minus. If it's a minus, you plus. You're still practicing it. You will be for 4 years, so at some point it'll become second nature. You do that in geometry. You solve equations. You solve equations for 4 years in high school. It doesn't matter what you call it, you're solving equations. So you have to have 4 math credits. It's 4. Is it 3?
Yeah, this one was 3.
Senior year. Let me look at
So
it.
how many?
My school I started out, you had to have 4 years of math, but maybe it's 3.
Yeah, they said it was 2 algebra.
And then you can graduate. I think colleges want 4 years of high school math. So you can graduate with that, but I think to get into college, you need to take all 4 years of math.
I already took algebra 1 in middle school.
Am I taking it again?
Yes.
You took pre-algebra 1.
So you'll solve equations
Am I
like
taking it
this,
again?
geometry and algebra 2, and then you have
You sure
options
didn't say
senior year.
pre-algebra 1?
Yeah, it's just a little more challenging. You're not the only one. All right, let's try it again. Oh, there's a typo in this. I'm gonna correct it right now. No, it's this 93. I'm just gonna rewrite this whole thing. It should be 9 to the x plus 1 equals 27 to the 4th. Because 93 is not a power of 3. And the problem won't work. Which, if you can't create the same base, you do something called a logarithm, which you'll learn in algebra 2. All right, so let's talk our goal. Our goal is to create the same base. Cameron, have you written this down yet? That the goal is to create the same base? Because that is something that you will forget. And if you forget that goal, there's no way to begin. Just looks like nonsense. So, Dallas, what are your thoughts about 9 and 27? How can we rewrite them? Are they powers of the same number? What number? Well, when you think of 9, what number do you think of? Smaller than 9? 3, right? So let's try powers of 3. Because that's the number you think of. So I'm going to think 3 to the first is 3. 3 squared is 9. Does anybody know 3 to the third power? 27. All right, so 9 and 27 are both powers of 3. That's not something you're going to come up with naturally. You have to practice this. So I'm going to take 9 and I'm going to take it out of the problem and I'm going to replace it with 3 squared. I'm going to take 27 out of the problem and I'm going to replace it with 3 to the third. So my new problem has a 3 squared where the 9 was and a 3 to the third where the 27 was. And that's just number tricks with numbers. Math trickery. So we practiced this last week, and this is why you practiced it last week, so you could solve equations. We're going to distribute our exponents. You multiply exponents that are written outside parentheses like that. So that's 2x plus 2 equals 3 to the 12th. Now we've successfully created the same base. You can drop the base and equate exponents. So I'm going to cross the 3's out. Exponents. And then I'm going to do 2x plus 2 equals 12. And then from there, hopefully you're relying on past knowledge on how to solve a multi-step equation. Hopefully from here you can kind of do a little bit of an autopilot. You'll subtract 2 from both sides, and you get 2x equals 10. Yes, divide by 2, autopilot. That's autopilot math there at the end. That whole beginning is new, is uncomfortable. You got to question it. You got to work. You got to ask questions. You got to teamwork. You got to work together. The end should be autopilot. We're going to do one more problem, and then we're going to do your assignment. Yeah, we don't have time. Third period, we're going to do a word problem, and then I can start maybe your assignment with you. Yeah, it's here. Yeah, 9 to the 6th equals 27 to the 4th.
No.
Great job, Akeem. Yes,
No.
great job. Okay. So this is a really important type of equation. The exponential equation is used for biology so much, for bacteria growth and viruses, and all of the scientists studying COVID are using exponential functions because that's how bacteria and viruses grow. So this is a real world problem. These are used so much to simulate bacteria growth and bacteria decay, population growth in every species. It's really important in biology. So the population of a culture that begins with 40 bacteria doubles every 8 hours. So you've learned how bacteria can double in class, how it grows. Here is the actual equation that shows this particular bacteria. Starting with just 40, if it doubles, the base of the power is 2, and it doubles in 8 hours, that 8 shows up in the exponent. All right, find how long it takes for the bacteria to reach 20,000. So how long do you think it might take for starting with 40 little bacteria to have 20,000 bacteria? This equation is going to show us that. So we're going to take the P out, and we're going to put 20,000 in because that's what we're trying to solve. So 20,480 equals 40 times 2, and this exponent t over 8. We're going to need a calculator here. Okay, what I'm going to do first is I'm going to divide both sides by 40 to get this equation more simple. I'll divide by 40. So somebody with a calculator, what's 2,480 divided by 40? 512 equals 2 with an exponent to the 8. Now we're going to create the same base. Cameron, what are you thinking about the number 512? 2 to the what power?
20. I don't know. 25.
So 2 to what power is 512? Let's start high. I agree. Let's start high. 2 to the 6 is just 64. 2 to the 7. 2 to the 8. Let's do what's 2 to the 8, you guys?
How do I do this question?
2 to the 8 is 256. So 2 to the 9. All right, what's 2 to the 9th? 512. So we're going to take 512 out and put 2 to the 9th in. That's cool. That's math. So 2 to the 9th is 2 to the time over 8. This is doubling every 8 hours. Now we can drop the base. And we have that 9 equals T over 8. How do you solve that? Autopilot. How do you get T alone?
You multiply t over 8 by both sides, or 8, yeah.
T is 72, y'all. Listen to this. Starting with just 40 bacteria in 72 hours, it grows to 20,000. This is how you get a stomach bug. Okay, you touch something, you just get 40 bacteria, almost not 40 little cells. You ingest it. In 72 hours, that bacteria grows to 20,000. And then you start throwing up because your stomach is full of bacteria, right? Well, that's true for viruses, but you don't build immunity to bacteria. I don't know. I don't get your joke, Johnny, but yeah. So anyway, this is how bacteria and viruses grow so quickly. If something doubles, it can grow quickly. It can get really big really fast. All right, you guys wrote your assignment down. Start it now.